All right, so now that we kind of did our little review and I kind of cut and pasted these from the other page and brought them over here with us. So these are our main identities we're going to use. And at some point, you should try to have these memorized, but you know, if you don't, you don't. So what you want to do when you verify an identity is you want to look at which side is, for lack of a better term, messier. Which side needs more work? Which side do you think needs to be simplified more than the other? Because sometimes they're both going to look like they need to be simplified, but there's not necessarily anything you can do with it. So this one is pretty obvious because cosine really can't be simplified to anything other than cosine, right? It's not, it can't be written in terms of sine or cosine again because it's already written in terms of cosine. And, you know, it's doesn't fall in this realm of what we want to do. And writing it as like 1 over secant would be completely counterproductive. So you look at this other side and you go, oh, yeah, I see some stuff there. All right, so let's deal with that stuff. So 1 minus sine squared. So we deal with this top one first. So we're looking at this top part here, and that's going to be this one right here. Is cosine squared equals 1 minus sine squared. So we're going to take that and we're going to put cosine squared in place of that. All right, we'll put our fraction bar. And then let's change colors here. And then cosine theta can just be left as cosine theta, right? So cosine theta. And then that equals our regular cosine theta. Now, when I'm doing these trig identities, you leave one side entirely alone. You work on one side, and the other side basically stays constant. So it doesn't matter how many I got to do here. It's always cosine theta, right? You're not messing around with this. You just leave it because this isn't the side we're working on. We are working on the left side in this problem. All right, and so because of that, take a look at this, right? So cosine theta squared, right? Cosine squared theta can be written as cosine theta times cosine theta, all right, because it's two of them. And we put it over 1 cosine theta, and then you get this really cool thing where they cancel. And then when you get to the point where one side equals the other side and they look exactly the same, that's when you know you are done. All right, and so we just kind of went through this. We only had one substitution step. We didn't really have a lot of algebraic manipulation we had to do in this one because, you know, other than just recognizing that these make this pair of cosines make 1 because cosine divided by anything divided by itself is 1. And I loosely use the word cancellation, but what it really means is you can replace it, right? You can replace it with 1. And because you can replace it, it looks like you made it go away. And you really didn't. You're just writing it differently. So we wind up with cosine theta equals cosine theta, and you're good. All right. And so I am now going to take this and get rid of it so that we have it. Okay. And then I am assuming we are all good with this stuff over here. So I'm going to do this. And then we are going to, let's see here, go delete. All right. And so now let's quickly write down our identities that we need again, just so we have them. So you need, and if you do this a couple times, you're gonna be like a rock star at this. You're gonna be like, oh, this is so easy, right? But you got to do it a few times to get used to it. So those are cosecant and secant, right? And then tangent, cotangent, right? Tangent, cotangent, theta. So we've got sine over cosine, and then cosine over sine, because they're inverses, or sorry, there I go again. The reciprocals of each other. Then you got your sine squared theta plus cosine squared theta. It doesn't really remember what order. It doesn't matter what order you write it in, right? Sine squared theta equals 1 minus cosine squared theta, and then the other one equals 1 minus sine squared theta, and then we have our tangent cotangent. So 1 plus tangent squared theta is equal to secant squared because they both have that cosine in the denominator, and then 1 plus cotangent squared theta is equal to cosecant squared theta. All right, great. Thanks for bearing with me for that. So look at this one, right? It's kind of like, all right, what are we going to do? Well, sine theta, cosine theta, you can't really write that any other way than just that, and you can't combine it because this is as condensed as you're going to be able to get it. So we kind of know that what we're going to do is we're going to leave this side alone. So what I'm going to do is I'm going to, just to prove a point, is I'm going to just write this out a couple times to show that, hey, we're going to leave this be, right? We're leaving this side alone, and we're working on this side. And so now what I'm going to do is I'm going to find different ways to write these things, if possible, in terms of sine and cosine, or if we've got these squared things, how can I use these Pythagorean identities to maybe write it as one term instead of two? So tangent of theta is just sine over cosine, right? Sine theta over cosine theta. And then 1 minus sine squared theta is this guy right here, right? This is our cosine squared theta. So you got the minus cosine squared theta, all right? And so what I'm going to do now, just to prove a point, I don't normally do this when I do these on my own, but I'm going to write cosine theta out twice, just to show that's this right here means this, right? And this. That's what it means. It means there's two of them. All right. And so now if I combine these, right, and I put them all over the same denominator like this, and then let's just take our cosine theta and just line it up sort of in the middle. We'll write this down just because that's what it is. You get a cancellation of one pair of these, right? And so these two cancel, and you're left with sine theta, cosine theta on the left side, and now we have gotten it to a point where it equals the right side. So these are, I'm kind of taking a little liberties and making these take a little longer than they need, but I just want to prove a point, show that you're just working with one side, and then you work on that one side until it looks like the other side. And that's literally, you know, the whole point of this. So hope this is helpful. The next video we'll do a couple more examples of these, and yeah, and we'll see you there.